this project, it is going to be present the solution of a specific problem related with the topic of derivatives. In order to be able to solve this given problem, the theory of the first derivative test and second derivative test is going to be applied and delayed.
Okay, to solve the second partial project, all the procedure needed was firstly to analyze the given data. After that, understand that data of the given problem. Next, to identify all the procedures needed in the problem to resolve. Most of the procedures needed to solve the second partial project were learned in class. The other ones were investigated, such as graphing it. Then, to solve the project problems in order, because if you don't make them in order, you will have troubles with making. You can make the H without making the and Z. Then, after that, we had to graph the functions, and finally to make a precise equation in order to finish the partial project.
We are being asked to find the restrictions in the domain x and y intercepts, symmetry, vertical asymptotes, and gaps. Horizontal asymptotes, the first derivative, the ID test, the second derivative, and the concavity test. The function can be factorized. Restrictions. The denominator can't be 0, so we have -1 and 1. To get the vertical asymptotes, it's needed to have limit as x approaches 1 and -1. And in order to get the horizontal asymptotes, it's limit as x approaches infinity. For getting the first derivative, it's needed to use a quotient rule. And we got that the derivative is 3 over x plus 1 squared. To get the second derivative, we also use a quotient rule. And the result was -6 over x plus 1 to the 3. Now to do the ID and the concavity test. For the ID test, we need to equal the first derivative to 0 to see if there's any critical point. The function only has one, and it's the gap. So we use a smaller point and a bigger point. In this case, we chose -2 and 2, and we substituted in the derivative. When substituting, we got that both of the signs were positive, so we have that the function has an increasing behavior. For the concavity test, we equal the second derivative to 0 to see if there are any critical points. Since there's only one critical point and it's the gap, we use the same smaller and bigger point, -2 and 2. One point had a positive sign and the other one had a negative sign. This means that one goes concave upwards and the other one goes downwards, and this can be seen in the graph. Here's a comparison between the original function and the first and second derivative.
Well, the conclusion of the project is after an extensive process of investigation and studying the topics learned during the different calculus term, the team was able to solve the second partial project. That was using all the skills and knowledge to solve the problem. At the beginning, the team